Okay, this is the start of Chapter 3, Newton's third law. So to begin, let me state what Newton's third law says, and that is that forces occur in pairs. And if there is a force of A on B, automatically there's a force of B on A that is equal in magnitude and opposite in direction to the original force. These two forces are a Newton number 3 pair. Please note that the way you get the reaction force is to change the object and the agent, and therefore they act on different objects. The force on the left side of the equal sign acts on object A. The force on the right side of the equal sign acts on object B. As an example, let's say we have a hammer hitting a nail, and the hammer strikes the nail, drives it into the wood, and delivers a force of the hammer on the nail, which is to the right, but the nail will push back on the hammer. That will be the force of the nail on the hammer to the left. Another example would be two boxes or crates or blocks of wood on a horizontal surface where let's say that their block A is being pushed to the right. And in that case, now that force is not shown, but what's shown here is that if box A is being pushed to the right, then there will be a contact force between box A and box B, and there will therefore be a Newton number 3 pair. The force of A on B, which is to the right. This is the force, the agent of which is A and the object is B. But then B will push back on A, and that will be this leftward pointing force, F of B on A. The agent for the leftward force is B, and the object is A. Okay, so one of the conceptual tools in this chapter is an interaction diagram. And the key idea here is that we typically have a system that we want to analyze. So for example, box A and box B in the previous example would have been an example of such a system. And in that system, there will be forces between the two objects. Those are considered to be internal interactions. And then outside the system, there will be an environment which has perhaps exerts forces on each of A and B. And so the system consists of, in this case, A and B, and objects that exert forces but whose motion is not of interest, for example, such as the Earth, form the environment. So in this case, that would be C. So we're going to see examples of this as we work through some of the material in Chapter 7.